Hey, this is Jody with weldingtipsandtricks.com with another weekly video. We're talking about vertical uphill MIG welding today, and the reason that comes up is because I did a little quick repair for somebody on a forklift a few days ago, and there was vertical uphill MIG welding, and also we knocked a little chamfer on it was a fillet weld, but we knocked a little chamfer on there to get a little bit more throat size on the weld. So that gives us something to talk about today. So that's what we're going to do. Here we go. This has become my kind of like my go-to vertical uphill technique with MIG, and it's a series of triangles, and it looks like this on a diagram. It doesn't really matter on a T-joint which direction you go, clockwise or counterclockwise. Matters a little bit on a lap joint, not much on a T-joint. Again, we're just tracing the front edge of that puddle and then coming straight across and then going up and tracing the front edge of that puddle again, and it is basically a series of triangles. And the reason it works is because the leading edge, front edge of the puddle is where the penetration happens, and so that's what you want to pay attention to, and you want to trace that front edge, and that works. It keeps that arc up on the front edge of the puddle instead of welding on your puddle all the time and just rolling it ahead. And this is one way to test the joint like this, a fillet weld T-joint. I welded it a little bit offset center so that I could tack it to this big plate and just whoop on it a while. And it is a down and dirty test, and it works. Give you a really good idea. Now the reason I'm doing all this today is this little repair here, and I've got a chamfer knocked on that big hunk of steel right there because it only had a very small fillet weld on it, and it popped off, and it was just laying up there, no one knows how long, just waiting to fall down and give somebody a tremendous headache or worse. And I don't want to put a single pass small weld like it had before. I want to put two passes on it, and I'm going to knock a bevel on it. And before I do that, I'm going to run some 1/4-inch plate here, and we're going to whoop on this one too after it's got two passes on it. With a chamfer on it like that, it increases the throat size of the weld tremendously. You get penetration on the first pass. Not only that, but you get a little preheat benefit. And then you can come across with a second pass. And this is actually a different joint. It takes a lot of joints to get these videos done sometimes, but I'm using this very same technique, just a little series of triangles like that, even though I'm down in that V in the chamfer. Same thing as I would do on a lap joint like this. You see, I'm going counterclockwise because I'd like to be kind of going downhill a little bit on the corner there. And one way to test them other than a hammer is just slice and dice like this and do a little polishing with maybe you don't really need to go much thicker, much finer than 120 grit on a flap disc or a sanding disc, and then some I'm using some passivation solution here for taking heat tint off stainless steel to reveal the weld nugget, and that works really well for kind of gauging your penetration. Another reason for knocking a chamfer on it and doing two passes would be a situation like this where you just don't have room to put a large fillet, and so you're limited on how big a weld you can put on there, so you have to make a chamfer in order to get more throat size. So this is the second pass after putting that first pass in that beveled piece, and like I said, it gets a little preheat action, and now this is the second pass going uphill here. I'm just pausing on the sides, not spending much time across the middle, and that's what I wind up with, a nice large size weld, which would be overkill for this 1/4-inch, but it sure does hold up good here. I mean, it doesn't even want to give. You can just feel the difference when you hit it. It doesn't want to give at all, and it's reached a point now where it's not giving at all no matter what I do. I can hit it all day long here, and it's give all it's going to give, and so that makes a lot of difference. Now, would be slightly over welded for 1/4-inch, but it tells me that the parameters are pretty good, and then it's going to hold up pretty good on that big thick chunk of steel on the forklift. Now that's the single pass weld right there. It actually passed. It bent over like that without even failing, but it started to give, started to open up a little bit, and so you can just see that the other one passed better on a fillet weld brake test type situation. Alright, getting back to the actual job here, I don't know what it is about a welder's personality, but I've got a bait of it. I don't like to ask for help. And so having a one-hand clamp like this when I'm up on a ladder or something like that, this is a ratchet style clamp from Strong Hand Tools. It suits my personality just fine because even though there's people in the shop today, I'm just reluctant to say, hey, would you give me a hand over here? So also this is a Strong Hand ground clamp. It's kind of a cool little cool little tool. It's got a solid copper piece on one side, and I have ground a nice clean area on top and bottom there. So I know I need to have a good ground for getting good tacks and everything with MIG welding, and also don't want to ground through the forklift body at all. I want to make sure that I got a solid ground through the piece there, because I don't want to ground through bearings or in brackets or anything else like that. And that's always good practice when you're doing automotive work or welding on anything from an airplane to a tug. Ground directly to, as close to the piece you're welding, so you don't ground through any bearings or anything like that. So we'll get 4 tacks on this thing, and then we'll run the forks up and down and make sure that everything's cool before it's welded up. And we'll proceed. So like I said, we're going to run it up and down a little bit just to make double sure that everything is like it needs to be and didn't do something squirrely. And like I said, this piece, the welds just broke on it. Who knows when, because it was just laying up there for probably months. One weld looked all rusty, so it had been failed for a long time. The other one was pretty fresh, but that would have really hurt to fall on your head, and it's just, I don't want that to happen again. That's why I'm taking a little bit of care and beveling and putting 2 passes and even checking the, testing some weld joints beforehand. And so that's almost done. I've still got to wrap those corners and make it look a little bit better, but the job is done. Now, just a quick reminder, I put all my videos on a 4-disc set every year and offer them up for sale to kind of support this video habit of mine. So if you like what we're doing here and you want to have this in your welding library, or just want to support welding tips and tricks, go to weldmongerstore.com and you can learn more. Hey, thanks for watching. Appreciate your time. We'll see you next week.